If you are not familiar with how to write numbers in scientific notation, then you need to focus on that in your book and be sure that you're familiar and understand scientific notation. I'll give you a very brief summary here of scientific notation and how to do that. If you have the number 4,184 and you want to write that number in scientific notation, standard scientific notation has one number before the decimal. Right now in this number, the decimal point is at the end. So for standard scientific notation, I would need to move the decimal 3 places, because typically I would write 4.184 times 10 to the what number goes in the exponent. Well, since I had to move the decimal 3 places, and I moved the decimal 3 places left, I would write times 10 to the third. 10 to the third is the same thing as a 1 with 3 zeros after it. So in other words, 4.184 times 1,000 is 4,184. What if I wanted to record the number 4,184? But if I look at this first number, how many significant figures are in that number? There's 4 sig figs in that number. The exponent in your scientific notation has nothing to do with significant figures. You only look at the numbers before your exponential function to determine sig figs. So let's take this number, 4,184, and instead of having 4 sig figs, what would I do to make it 2 significant figures? 2 significant figures, I would write 4.2 times 10 to the third. Notice you can't take it and just write 42, because that is not the same number. To 2 sig figs, it would be 4,200, and so in scientific notation, that would be 4.2 times 10 to the third. So, when does the number in the exponent, when does it become negative? Well, that's when you're dealing with a decimal. If you had to write 0.0102 and you wanted to record that in scientific notation, again, the standard way to do it is to have one number before the decimal. So that means I would need to move this 2 places. This number would be 1.02 times 10 to the minus 2. Likewise, if I take a number, if I said 4.78 times 10 to the minus 6, can you take that number out of scientific notation and write it in its decimal form? Well, the negative 6 tells me I have to take this decimal and move it 6 places. 1, 2, 3, 4, 5, 6. And so I'm going to put that decimal here, so that number would be 1, 2, 3, 4, 5. That would be that number in scientific notation. Let's look at how I use significant figures and scientific notation in calculations. Well, if I'm going to multiply some numbers, say I'm going to multiply 1.02 times 4.1 times 0.0478. And I'm going to use my calculator and enter those numbers. My calculator tells me that the answer, when I multiply those together, is 0.1998996. Well, that's a lot of numbers. Do I have to write all of those numbers down? No. How many digits I write down depends on my significant figures. Go back to the numbers we used in the problem. 1.02. How many sig figs are there in that number? 3 sig figs. 4.1 has 2 sig figs, and 0.0478 has 3 sig figs. Remember, zeros at the beginning of a number are never significant. So the numbers I used in my calculation had different numbers of significant figures. Whichever number has the least, in this case 4.1, it only has 2 sig figs. That means my answer can have only 2 significant figures. So how would I report that answer? Remember, zeros at the beginning of a number are not significant. They're just placeholders. I'm only going to report 2 sig figs, and in this case, I'm also going to have to round. So this number would be reported as 0.20. Zeros at the end of a number are significant if they also come after a decimal. That answer has 2 significant figures, and that would be the correct way to report that answer. What if you're adding numbers? Well, again, to review this example, when you multiply and divide, you use the number in your calculation that had the least number of significant figures. When you're adding numbers, let's say we wanted to add 4.100, 6.2, and 9.847. There's a different way to do the rules when you're adding numbers. If I add these up, I get 20.147. I don't have to look at the significant digits. I simply look at the decimal places. Which of these numbers has the least number of decimal places? There's only one decimal place in that number. Therefore, my answer has only one decimal place. My answer would be 20.1. Notice here, I know I want one decimal. Since this number is a 4, that tells me that I don't round up. If this had been 5 or greater, I would have rounded up. Do not round from the end. Some students will take this 7 and say, oh, well, that rounds that to a 5, which then rounds this to a 2. That would be incorrect. This is your number you have. You look at it as it is. This number's a 4. Obviously, 47 is below the cutoff for rounding up. It would have to be at least 50 to round up. So the correct answer here would be 20.1. So again, realize there's a different set of rules for multiplying and dividing. You look at significant figures. Adding and subtracting, you look at decimal places.